This is question 4, and diodes and conduction. So there's two things that are really going on here. And you need to write a plan for 12 marks. So it's telling you about diodes, just in case you've forgotten. So you know what a diode is. It'll mean that current can pass this way, but that way no current. And it also says that the potential difference, or the voltage, is the threshold. So it will do that, but only if the threshold potential difference. So only if the potential difference is high enough. And what do we need to do? We need to do a couple of things. First of all, the easiest thing really is to think about the direction. So work out which direction is which, and finding the threshold, and these, which will allow a current. So we need a circuit that's got one of these in. So our circuit is going to have one of these in. So that's my diode. In our circuit we're going to have something to generate some potential difference. So the thing that's going to generate the potential difference is 12 volts. There we are. So that's the that's the box that you turn the twiddly thing to alter the potential difference, or the voltage. Then we're going to need some resistance in the circuit, or a bulb, or a resistor. And so let's put a bulb somewhere. So we can have a resistor, or we could put a bulb there. And let's have a let's have a switch as well, just so we can turn things on and off. Okay. And then, and when you draw this, you could label it, and then they could see using the right equipment. And we are measuring we're finding the potential difference. So if we're finding the potential difference across this diode, well, we need to remember we need a voltmeter, but where do we put the voltmeter? Do we put it in series or parallel? Well, the answer to that is we need to put it in parallel. So there's our voltmeter. Okay, and it'll measure the voltage across the diode. And we want some indication of where the current is passing. So you could use that, using a bulb possibly, or we could, probably better to actually measure the current, and you do that with an ammeter in series. So we have got, there's our circuit, and we need a hypothesis and selection of justification of equipment, and that sort of thing. So let's start off with a hypothesis. So hypothesis, well, we don't think this diode will conduct at all in one direction. So the diode will only conduct in one direction, regardless of the potential difference. and in the other direction it will conduct, but only beyond a certain value of potential difference. In the other direction, the diode will conduct, but only above a certain potential difference. So that's our hypothesis. And then we are selecting and justifying our equipment. Well, we've selected it, we've got our diagram down here, and we could explain what we've got. So we've got the diode, and we have got variable, got a power supply. Let's put that in. Power supply, and this supplies, for example, 0 to 12 volts potential difference. We have got a resistor, provides resistance in the circuit. We have got switch, so it turns circuit on and off. We have got, let's not forget the diode, which conducts only one way and if above threshold potential difference. I don't think we really need to say that. What else have we got? We've got voltmeter to measures potential difference, measures potential, can't spell difference, and we're going to put that in parallel. We have got ammeter, measures current, and we're going to put that in series. So that's our equipment. Our experiment is we put the diode one way around and just increase the power supply, and first of all we can do that to measure which, the one direction hopefully will not be able to conduct any current. So our instructions, so method, so start with diode one way round, increase the potential difference from 0 to say 12 volts. And then what we're actually going to measure, we're going to note the potential difference when we get any current flowing. So, observe if current flows, and write down the voltage when current starts to flow. So record potential difference in volts when current starts to flow, if at all. Then what we're doing then is turning the diode the other way around and repeat. So switch diode to the opposite direction and repeat the experiment. So it does ask us for control variables. So let's just switch colour here. Control variables. So things like, we'll do this experiment all at the same temperature because that might affect resistance. So use same temperature for each experiment. Use the same equipment, so e.g. the diode, use the same diode just in case there are different types of diode available. Same wires, same power pack and so on, same lengths of wire. So there's a couple of control variables. What else does it want? It wants us to look at health and safety. So health and safety. So things like, we keep water away from this circuit, risk of electrocution, so risk of electrical shock. How could we minimize that? So we'd set up the circuit and then move the switch so that we're not going to get an electrical shock. So set up circuit, then move switch to on. Things like water as well, make sure there's no water near the circuit. So make sure no water or drinks. Near the circuit. And that's a reasonable overview of what you're doing. And that should provide evidence for or against your hypothesis.